Good afternoon, everyone, and welcome to Demo Day of the Rice Alliance Clean Energy Accelerator. I was looking at the attendee list. It's great seeing so many of our community friends here today. And it's nice seeing so many new names as well. So thanks for being a part of this experience and sharing in the celebration of our very first class. My name is Carrie Smith, and I'm the Interim Executive Director of the Clean Energy Accelerator. And as most of you know, we had originally planned for this event to be in person today, alongside the Energy Tech Venture Forum. But when the need for a venue change became apparent, we shifted to a virtual experience, but designed it in a way that still allowed for lots of opportunities of exposure and networking. But in retrospect, though, maybe it's a good thing we went virtual because no Rice Demo Day would be complete without the appearance of a tropical storm or a hurricane. So for the non-Houstonians online today, Hurricane Nicholas blew through here just 2 days ago and caused a fair amount of disruption. So I'd like to think the universe was telling us something and framed this virtual experience as a silver lining to what could have been an otherwise huge travel mess for y'all. But regardless, we're glad you're here and could still join us today. And we do look forward to seeing you in January outside of hurricane season when we're able to meet in person at the Energy Tech Venture Forum. But weather and pandemics aside, let's get the energy flowing, if you will, and highlight some background that brought us here today. At the beginning of this year, and through the support of so many of you, the application season for this first class opened up, and it drew worldwide interests from a variety of early and later stage startups. Applicants brought forward a wide range of energy transition solutions, which made for a very competitive selection process and also validated a growing focus on energy transition. So serving multiple energy sectors and with headquarters spanning across the United States and Canada, we invited and welcomed our very first class of 12 startups, which is the group that you'll hear from today. We saw in these founders enormous potential and designed a concentrated program that would help meet and advance their energy transition objectives. The entrepreneurial drive of these founders, along with their appetite for learning, made for a one-of-a-kind 12-week experience that is culminating today. Their demo day showcases what they have achieved over the last few short months, and it's a celebration of their work, and we're super excited for you to meet them. Fast forwarding to June, when we launched on the 28th, we spent the next 3 months providing them with hyper-targeted training and mentorship focused on accelerating their business. By our estimation, through nearly 50 training sessions and over 150 separate mentor engagements, our extraordinary network of mentors and speakers and supporters and advisors threaded essential pearls of wisdom that helped founders learn and absorb key insights. And they also helped make those crucial connections with potential partners and potential customers. We're also excited for you to meet our team of executives in residence. We assembled this brilliant trifecta of energy-focused leaders who have worked alongside our founders and delivered essential guidance and wisdom that dovetailed with the startup issues and topics that we covered in our curriculum. Leveraging their industry knowledge, their expertise, and their network, Kevin, Mike, and Caroline worked one-on-one with founders to help them overcome and navigate those inevitable day-to-day surprises and challenges that every entrepreneur faces. You'll hear from each of our XIRs momentarily when they introduce you to their group of startups that they worked with. And finally, I'd like for you to meet Matt Pena, the Associate Director of the Accelerator and the newest member of the Rice Alliance team. Matthew is an entrepreneur and a Rice alum, and he will help lead us through our program today, which will follow this general format. Over the next 2 hours, we'll spotlight each of our 12 startups, and we'll give you an opportunity to hear their pitch and to ask questions. So as you listen to the pitches, get your questions ready. The startups will present for roughly 5 minutes, followed by 5 minutes of Q&A. As an attendee, if you'd like to ask a question, you may use either the raise hand or the Q&A feature of this webinar. Matt will unmute and call on you to ask your question. Or if you prefer, you can simply type your question in the Q&A box and Matt will read it if time allows. And just also note that we have built in a couple of super short breaks between our groups of pitches, just to give you some time to rest and to refresh your eyes. So with that, let's get to why we're all here and get to the business at hand. Let's face it, y'all didn't come here to hear me, you came here to hear them. So let's settle in, let's get comfortable, and let's enter the house of Doffing. The first pod of startups we'll hear from today was expertly led by Kevin Doffing with the energy capital of the future. So Kevin, if you're ready to roll, the spotlight is yours to introduce your group and share some remarks.
Thanks, Carrie. I really appreciate that. And anytime someone calls me an expert, I never want to call them a liar, but I do appreciate, the vote of confidence. We have a really great team here. With the Rice School, they just received their second year in a row notification that they're the #1 postgraduate entrepreneurship program in the country. And I think that is one of the reasons that you see this really great talent coming here. And I got to work with these great companies. Some of the advice I would always give them, centered around my motto of do less better. You're more likely to drown in opportunities than you are to starve from the lack of them as a startup. Don't get that shiny object syndrome and chase things around. But these companies have come a long way. They've done a really great job focusing on the opportunities that this program has really facilitated for them. There's no other accelerator program in the entire country or the world, I would venture to say, where you have as much access to industry partners, mentors, guidance, and opportunities for both strategic investment, but also strategic pilots and customers. This is a great program that I can only wait to see grow in the coming years. As we continue to work through the program together and get to know one another, I really look forward to our weekly meetings. I wish they could have been in person. I can only imagine what would have happened if we had some social lubricant to just go ahead and get those stories out there at the founder journey. But as it was, we worked over Zoom. We had a great time. This first company that you're going to hear from, Liz O'Connor with Aerolytics, I actually am excited. I get to meet next week at the Global Energy Show in Calgary. They're a fantastic company. And the last thing I'll ask of everyone watching these pitches is make sure to reach out to these companies, talk to them, help them. That's what's going to move the energy transition. And that's why I'm excited to work with these companies. So with nothing more, I'd like to introduce you to Liz O'Connell with Aerolytics.
Yes, and I'll do a brief introduction for Liz. She's leading off our pitches. She was voted most likely to be a superhero. After all, she is an alumni of a school where they refer to themselves as X-Men and X-Women and claims to have the powers to monitor and reduce greenhouse gas emissions. Liz, good luck. I can see you. I can see your slides.
Perfect. Thanks so much, Matt and Kevin. I appreciate it. Hi, everyone. Aerolytics is an emissions software company with a goal to enable lower carbon energy production. The latest IPCC report highlighted methane mitigation as a critical factor in slowing climate warming. Energy companies are facing rapidly increasing pressures to cut their methane emissions, which are 80 times more powerful at warming than carbon dioxide. It's time for industry to respond accordingly because this is a problem they can no longer afford not to address. In response, new regulations mean producers must now measure, reduce, and report emissions from thousands of facilities up to 4 times a year. But between increased compliance costs, the fact that producers have never before needed to measure their emissions in many cases, and mounting pressure from investors around ESG, producers need a solution. The cost of doing nothing is significant, including massive fines, mandatory shut-ins, and lost investment. To address these issues, we've developed Aerovis, a software platform that enables the digital transformation of energy sector emissions management. Now, there's no one silver bullet for emissions detection. Many technologies exist to measure methane, such as handheld sensors, drones, and satellites like the one shown here. Producers are being inundated with sensor solutions, and it's difficult to know what is best for their unique situation. First, our proprietary emissions modeling feature evaluates hundreds of technologies to determine the best fit for a specific producer. Based on the company's unique assets and our technology agnostic approach, The simulation model determines an optimized field program tailored to meet a client's emission reduction objectives at the lowest cost. This is often saving producers up to 40% on their monitoring costs compared to default monitoring methods. These savings are on the magnitude of hundreds of thousands of dollars for a medium-sized producer. The IP powering this tool is protected by trade secret and is the only commercial methane simulation tool of its kind on the market currently. Next, once the field data is being collected by third parties and different sensor companies, Aerovis uniquely aggregates and analyzes it on a centralized platform, connecting the operations team with other teams such as regulatory. Aerovis delivers up-to-date analytics such as progress on internal emissions targets, reliably discloses emissions metrics, provides emissions forecasting to link everyday activities to longer-term company targets. Our platform is not restricted by the borders of regulatory jurisdictions and has been built with scalability in mind. One of our main competitors to date are in-house solutions like Microsoft Excel, which are error-prone and not scalable. Our other competitors retroactively report on emissions for compliance purposes primarily, whereas Aerovis enables producers to take a proactive approach to emissions management by providing real-time updates and informing day-to-day decision-making. With over 1.3 million wells and facilities across North America alone, emissions management is a global market opportunity. The 198 energy-related methane policies worldwide create a strong regulatory market driver for emissions data management. And this is growing, with the EPA planning to reinstate federal-wide methane regulations in the coming months. As of 2021, we've entered into our first software pilots, including one with Canadian major Cenovus Energy. We have closed our first round of financing earlier this year and have since grown our team to 13 employees. In spring 2020, we finalized our MVP. Come 2023, the focus will be on becoming a global trusted source for carbon emissions management and disclosure. And we'll be working to incorporate all Scope 1 and 2 carbon emission sources into Aerovis. Aerovis is offered through a B2B SaaS business model with an average annual subscription for a medium-sized producer of around 150K. To date, we've received well over 500K in customer revenue, as well as several hundred thousand in grants. And finally, who's behind it all? Our founding team formed out of Canada's largest academic emissions lab, where we spent multiple years researching emissions across thousands of oil and gas facilities and collaborating with industry to understand their problems. We are well-recognized experts in the space and have published some of Canada's largest oil and gas emission studies. Our IP is founder-owned and exists outside of the university. Our upcoming objectives are to find US industry contacts to help with market validation, customer discovery, and product research. We are pursuing 2 to 3 US pilot customers and strategic partnerships to help with market penetration. We are specifically targeting progressive, medium to large upstream producers with a strong ESG culture and emission reduction objectives. We're also planning to raise additional financing in 2022 to support further US market entry. That's all. Thank you so much to Rice for this opportunity, and I'm happy to answer any questions.
Thank you, Liz. We'll now open it up for questions. You can either type it in the Q&A box or use the raise hand function, and I'll unmute you. We do have one in the QA box from Vincent. Aerolytics, are you connected to the PTAC effort out of Calgary on methane mitigation?
Yes, thanks for the question, Vincent. You can actually see the PTAC logo listed here at the bottom. So we do work quite closely with them on a few different projects because they're quite involved in this space. Absolutely.
Next question from Thomas Henry. Where do you see some of the barriers to getting pilots?
Yeah, I think, when you're talking about adopting a SaaS platform into an oil and gas company, it's not a quick process. There's internal security reviews. You need to understand how it might fit and integrate with existing systems like SAP, other software platforms. How does the data streamline between different, from the field into a product like ours? Who are the users? There's tons of different considerations when adopting a new product like that. So we've been working really hard to streamline that process, make the onboarding and training easy for our current pilot customers in Canada. And we're really excited about the opportunity to get that going in the US now.
Another question. Do you have statistics on methane emissions from abandoned wells versus active wells? How Do you deal with the hundreds of thousands, if not millions, of abandoned wells, and how can you help?
Yeah, that's a great question. So really what we're aiming with our platform is more emissions coming from active sources, and because that's really where the regulatory landscape is driving this right now, both in Canada, but state specifically in the US, and soon to be federally mandated through the EPA as well. There's requirements to directly measure your emissions through those active facilities. And so that's really where a lot of these sensor solutions are coming to play. With abandoned wells, there absolutely can still be fugitive, which is unintended emissions coming from those abandoned wells. However, the leaks are way, way smaller, and it's not quite regulated in the same way as the problem we're addressing with our current platform, which is more the larger fugitive and vented sources with active wells.
Very good. Another question. John Jeffers asks, this is clearly a very timely business to be building. What is your moat to shield your business from emerging competitors?
Great question. So we are an expertise-based startup. As I mentioned, we formed out of one of Canada's largest academic research groups. And so we really have a background in working closely with this data, understanding how all these different sensors can work together to make that optimized program. And it's just through that background. And our lab has even worked to develop some of these solutions on the hardware side as well. And so I think that's part of our competitive advantage is our background in the more data science, uniquely positioned around this methane opportunity. Our emissions model, as I mentioned, it's one of the kind of our main competitors in that space are actually more on the academic side within universities right now. And so this is really the only kind of commercial methane tool of its type. And that's really been built based off of our background, working closely with this data and our kind of programming knowledge around that.
Question from John Mossop. Hi guys, how deployable is your platform across different client facilities? Do you foresee any upstart costs?
Great question. So we've made our platform applicable to a few different sectors. So primarily upstream, midstream, and downstream sectors. We're talking to different companies across all those different broad umbrella of oil and gas. Within a specific company, it's absolutely deployable across the range of their assets. So whether that's 10 facilities to 1,000 facilities, that's the beautiful nature of a scalable SaaS product. There's no kind of limitation to the coverage of data or facilities and wells that this platform would be managing the data from. And in terms of costs or upfront costs like that, currently through the pilot phase, all of that onboarding and kind of working with a customer to get this adopted into the company, that's something that we're just working with closely, and there's no extra fees or additional costs like that. We're just really interested in getting this platform out the door, working closely with producers, getting feedback on it, and that's our main objective at this point.
All right, one last question from Raj Rapaka. Are platforms like Enablon your competitors? If not, who else is in the same space as you?
Yeah, great question. So a couple in our competitive landscape, there's other software companies that might be more focused on reporting, for instance, and regulatory compliance reporting. That's a big sector of our competitive kind of landscape. And as I mentioned during my presentation, we're really focused on kind of moving away from that more retroactive compliance value proposition to empowering producers with a more proactive day-to-day management of this. So that's certainly one kind of key segment. Other companies like the DIY Excel, that's also common because these are new regulations and new requirements. So companies are just looking for new solutions, and it's a really emerging kind of evolving space currently. So.
Thank you, attendees, for using the Q&A function. Thank you, Liz. If you didn't get your question answered, please contact the respective teams using the Whova platform or follow up using the email provided. Up next, we'll hear from Sizwe Lamini with PowerHV. Sizwe was voted most likely to enjoy the majestic landscape of Manitoba, especially its yellow fields of canola flowers. Sizwe, I can see you, and I can see your slides.
Good afternoon, everybody. We at PowerHV help companies to improve the performance of their assets with smart real-time monitoring that helps them to increase revenue and reduce losses. The problem that we address is that the sensors which are out there, especially for monitoring of methane leaks, were developed before the regulations that are out there. And those regulations require monitoring per equipment, as well as the rate of leak of methane from those pieces of equipment. At PowerHV, our solution helps operators to comply with those regulations for methane monitoring. We detect the leak at the piece of equipment and not just at the perimeter as our competing products do. We also apply edge analytics in order to diagnose the actual condition of that piece of equipment and not just send data to the customer. And we go one step further. We allow the operator to predict when a failure is likely to happen by monitoring changes in the vibration signature of a piece of equipment. With all this, we help the operator to comply with regulations. Many types of competing technology for methane detection, including satellite surveillance, as well as laser detection, which is normally placed at the perimeter of well sites, including infrared cameras, as well as drone systems, none of which comply with regulations for monitoring of methane leaks. With our types of sensors and software, for instance, at a site with 6 wells, we would put 10 sensors. The reduction in methane would be 19 tons per year at that site, with a payback of 2 years and an annual return of $20,000 per year at that site from the reduced methane leak, as well as from the reduced carbon taxes. An operator, for example, with 140 wells, that would be a saving of 1,400 tons per year of methane, a payback of 2 years, and an annual saving in methane and carbon tax of $1.5 million per year. Globally, in the methane leak problem, there are new laws that have been passed which require monitoring of methane and reporting of methane leaks. These are new laws, most of them developed before those sensors, after those sensors which are currently deployed. Going together with these laws is an increasingly activist, environmentally active public who have access to data, for instance, from the IEA satellite website, which can indicate any well site which may be in the vicinity of that activist public, who can then take that operator to court and litigate. Globally, the size of the problem is $117 billion per year. In Canada, it's worth $2 billion. In the United States, it's worth $12 billion. As a company, we started out servicing the electricity sector. In 2020, we sold $400,000 of sensors and bushings to the electricity sector. In 2021, this year, we are on track to sell to generate $2 million in revenue. Last year, we raised $350,000 in investment. And this year, we have recently been funded with $2 million to help us to scale our operations and grow the company. We aim to come back to investors in about 2 years' time, in 2023, to raise $10 million in order to keep growing our company. We have an experienced technical team, as well as finance and business development team. On our board of directors, we have investors. We also have advisors who have deep industry experience in procurement and sales, B2B, in the sectors where we operate, as well as technical experience in oil and gas and electricity sector. We are members of industry associations in the sectors where we operate, which is the electricity sector and oil and gas. We have sensors that we deployed in the electricity sectors that we have changed the enclosures to make them adaptable to the oil and gas sector. We have not changed the core platform and technology, and we have bushings which are deployed in the electricity sector. What we are asking for as we present today is introduction to medium-sized well operators who would like to do some demonstration pilots, and we would like to have some partnerships with some of the other sensor manufacturers who would want to use our type of technology in addition to what they have currently. Thank you very much. I'll be able to take questions.
Thank you, Sizwe. We have a couple questions already loaded up. First one is from Vincent. What is the size of leak detected at what distance range of action?
We focus on what is classified as large leaks. So those large leaks have a flow rate which is specified in the regulations. I think if I remember correctly, it is, it's 135 feet per second or something like that. But we focus on detecting larger leaks, and we focus on the equipment that is emitting those leaks, such as compressors and the equipment that are specified in the regulations. Thank you.
Another follow-up question from Vincent. Where are your sensors built? Where is your IP? And what is the sensing technology? We build our own sensors. We have our own proprietary sensor specifically developed for partial discharge with detection. We add methane detection sensors, vibration sensors, audio, and other sensors, so that when we detect a methane leak, we have multiple sources of inputs that allow us to know that this is definitely a leak and not a false alarm. And our intellectual property, we have
one patent, which is for bushings, and we are filing some patents for sensors. So those are ongoing and in progress.
A question from Zanub. How do you differentiate between other methane sensors available in the industry and your technology?
There are many types of sensors. Our focus is monitoring per equipment. So many of the other sensors, they monitor at the perimeter of the site. So they don't give information about the specific piece of equipment and its leak. You need an additional resource, which is normally a person with another additional instrumentation that they walk around and look for the actual location of that leak.
Okay, we have a few additional questions in the chat. Just a reminder, please try to use the question and answer function if possible. First one is from Raj. He's looking for a couple more specifics on the sensor. Are your sensors at the ground level or elevated? Do they allow you to pinpoint the source of the leak and the leak rate, or just give you concentrations at the sensor? And does it detect only methane or other volatile compounds and pollutants?
Yes, at this stage, we are focusing on methane detection. We locate at the piece of equipment. So wherever the equipment is located, elevated or on ground, we locate wherever that equipment is located.
Okay, we got a couple others in the question and answer box. How do you keep wind from affecting your readings?
So wind is always there, but because you are close to the location of the leak, and because we are monitoring what is defined as large leaks, the rate of flow, as well as the audio from that leak allows you to detect without any doubt that this is a methane leak, and you calibrate it by calculation inside the software to say this is the rate of leak of this type of methane leak.
Thank you, Jerry, for the question. Next one from Elliot. Are your sensors a complete substitute for alternative sensing methods, or would they be combined with alternatives for an optimized site?
We would combine them with alternatives for a site so that you would have your perimeter detection and you would have a specific location which is using our sensor. You can also use them as an alternative standalone at sites that don't have sensors. We are just optimizing and reducing the time that it takes to detect that leak and be able to address it.
A question from Andrew. What is your pricing model? Has this been field tested?
We have a pricing model that we based on competing types of sensors in the oil and gas as well as electricity sector. And we would normally, we have an element which is the hardware, the sensors themselves, and then a software license that would keep our engineers updating as the operating systems change. But we can discuss in more detail with individuals, after this discussion.
Very good. We've run out of time. Sizwe, I'd ask you to look at the chat. There's a couple other questions that I might not have addressed in there. Thank you, Sizwe.
Thank you.
Next, we'll hear from Kacheng Zha, who also goes by Greg, with CoFlow Jet Wind Turbines. Kacheng was voted most likely to offer a wind turbine in exchange for a favor.
Thank you. Thank you, everyone. I appreciate this opportunity to share our technology and business. Our focus is to develop wind turbines to provide the low-cost wind energy. So energy with a net zero emission is a necessity for global economy and life. We're continuing to develop economy. We need more energy. So wind energy as a clean energy must be increased dramatically to satisfy 2050 carbon neutral target. The U.S. Department of Energy, the target by 2050 is 35% electricity should be from wind energy, represented by the blue color here. But what's our status today? We only have 7%. So you can see very light blue. So we have a long way to go. We are at the early stage of enormous wind energy expansion. So what's the problem of the wind turbines today? One is that poor performance at the low wind speed. It doesn't generate much power when the speed is low, so many area cannot use wind turbine. The other is the overall lifespan is still too short, even though it's 20 to 25 years. That's still just too short from economic point of view. So people go large wind turbines and trying to get more energy, but very expensive manufacturing large wind turbines. So all this make the levelized cost of wind energy still too high. Here you can see the wind turbine size evolution. So today's wind turbine is offshore turbines almost like as high as the Eiffel Tower. So what's the solution? We provide a co-flow jet blade as a solution, which is unique and superior. By embedded fans inside the wind turbines, we suck in small amount of air near trailing edge, energize it, and eject tangential and near leading edge. This tremendously changes the aerodynamic performance, increase the efficiency and the power output. So we already have 11 patents issued based on 18 years research funded by government. We already received $2.5 million from the government. So first, the benefit of the cold-flow jet wind turbine is that we can increase the engine turbine power output across all wind speed. In particular, we are interested in low wind speed. We can use a higher angle of attack with a higher lift coefficient, more power output. But conventional turbine, when you go high angle of attack, they stored like this one. The spaghetti flow structure will not generate power when they are stored. But cold-flow is very clean, and we can increase the power, average power by at least 20%. In other words, capacity factor can be increased by 20%. We can also reduce the lower wind speed limit from 6.7 meter per second to 5 meter per second. This can enormously increase the wind turbine usage areas. The second benefit is that we can increase the inner span of the turbine power output. The current turbine is all cylinders shape there. They don't generate lift, they don't generate much power. Using cold-flow jet, we can substantially increase the lift and the power there. The third benefit is that we can expand the usage of downwind turbine, which has the advantage of the blade is bending away from the tower to avoid striking. So this will allow us to reduce the mass and the manufacturing costs by 25 to 30%. But downwind turbine has the issue is that the blade will cross the tower wake in every rotation, which will generate fatigue load. Using cold-flow jet, we can remove this fatigue load. So overall, this advantage will allow us to reduce the levelized cost of energy at least by 30%. And we can also go very large turbine size, for example, 20 megawatts, which does not exist today yet. So the market size is about 100 billion this year and expected to be $2.2 trillion in 2050 with an 11% annual growth rate. Our revenue model is 60% will be from patent licensing, 20% from engineering, consulting support, and 20% from software licensing. We expect to have $837 million in 10 years with a 2.4% market share. So our potential customers or competitors or partners could be OEMs like Vestas, Siemens, GE, or energy majors like BP, Shell, other companies. So at this time, no other flow control technology shows sufficient benefits to be used on wind turbines except the cold-flow jet. Currently, we are in discussion with one energy company for potential investment and development. So the round A ask is $6.5 million for 2 years to demonstrate 30 kilowatt small downwind turbines, and commercialization will start immediately, and we'll raise the TIO from 5 to 8. So here's our technology team. So this is myself, and Dr. Ren is the chief engineer. Don is a retired Boeing engineer. Patrick has both technology experience and business experience. So that's the technical team on the left. On the right is the business team led by Dr. Johnson. He's also business professor at the UM. And Renee, Nancy, and David are all very experienced. I myself is a professor at the University of Miami. My background is mostly aerodynamics and aerospace engineering. So we already received $2.5 million. We welcome investment, collaboration. Let's work together to provide low-cost wind energy, and we want to get more with the wind. Thank you.
Thank you, Kacheng. Let's open up the Q&A portion. We have a question. Do you think about the end of life of those blades? How can we facilitate the recyclability of the blades?
We expect the lifespan will be increased at least by 20%, so to 30 years. Recycling, we are not thinking enough yet, but we do know that there are people working on that field. We would appreciate their work and work with them.
We have a question in chat from Tomiko. CoFlow, what sort of technology proof of concept has been demonstrated so far?
We have done that in the wind tunnel testing. You can see that here. I didn't put the results. We do have a lot of results. We substantially increase the lift coefficient, stall angle. It's basically stall free and reduce the drag.
We have a question from DC Palter. What's the business model? Do you plan to sell turbines or license the technology to existing turbine manufacturers?
We plan to do the IP licensing as the major business model, and also engineering consulting because we have the experience, design, and test this, and software. We have very specialized software for cold-flow jet. But we are very open to work with OEMs and to work together. But for now, IP licensing is the primary model.
We have a question from Rob Tucci with the Texas Halo Fund. What is the projected cost of production of these blades interim of a delta over current blades?
The cost will be reduced because the overall blade, in particular, we are more interested in going to the downwind blade, so it will be lighter and overall manufacturing costs will be reduced at least by 25%.
Question from Jim Allman. What are the problems with downwind turbines? How does your technology address these problems?
Advantage of a downwind turbine is that we can avoid the blade striking the tower, but problem is that blade has to cross the tower wake. I don't know if you know what is the wake. You can think about the wake behind the boat. Every time the blade rotation passing the wake, it will experience a fatigue load. Using cold flow jet, we can remove this fatigue load, and so that we can have a long lifespan of the blades.
We have time for one more question. With more moving parts in this design, what are your thoughts regarding the ongoing maintenance frequency and costs?
The moving parts is a very reliable one. Actually, most of the HVAC fan will be usable for these fans, but we want to make a special design, but the technology overall is very mature. So we are talking about a very low pressure fan, very reliable. We usually put the HVAC fan in the building for 20, 30 years. It doesn't break. Similar things will happen for this wind turbine, and low maintenance.
Thank you very much, Kachang and Joseph, joining on the Q&A.
Thank you. Thank you very much.
Our last House of Dauphine startup is Renewal Energy. We will hear from Kemp Gregory. Kemp is our resident Longhorn and voted least likely to believe that leaving well enough alone applies to idle oil wells. I can now see you and your slides. You're good to go.
Happy to be here. What you were looking at is an inactive well that was drilled in California's Central Valley in 1992, then produced valuable oil for decades, but not a drop in the last 2 years. It is waiting to be plugged and abandoned, an expensive process that fills the well with cement, removes all surface equipment, and tears down the power lines. Shouldn't we be able to put all of this valuable infrastructure and inactive wells to a new use? Because there are hundreds of wells just like it in this field, 50,000 like it in California, and over 2 million like it in North America. To further understand the problem, it is important to know that oil and gas companies are required to remediate every single well they own. These remediation costs can vary between $10,000 to $500,000, but are always a zero return investment, and these wells can be polluting locally and atmospherically. We offer a better choice: to convert an idle well into a gravity well. Renewal is currently testing our patented prototype built from off-the-shelf equipment, which stores gravitational potential energy by moving a weight up and down the wellbore, similar to how pumped hydro works. Our technology creates compelling conversion benefits for the oil and gas company and the environment. The energy storage features include a lower capital cost than lithium-ion by its projected 2025 cost, and the flexibility to participate in the most energy storage revenue streams on the market. It's important to understand that energy storage is required for renewable growth. Today's wind and solar capacity is sparse and supported by 284 gigawatt hours of energy storage capacity. In 2050, the wind and solar capacity will grow to this, supported by an estimated 1,300 gigawatt hours of energy storage. Inserting the inactive wells onto this map, you can see the fortuitous overlap. This infrastructure could be converted into 78 gigawatt hours worth of capacity by 2050. Now, Renewal estimates we can repurpose somewhere between 10% and 30% of all idle wells. But let's say the actual number is close to 20%. That still represents $58 billion of collective idle well liability. It is this money we are trying to get in front of and offer a better purpose for, using it to unlock the burgeoning energy storage market, which Renewal estimates could be a revenue stream worth $3 billion by 2030 from a projected 24% of the market share. Renewal has solid traction represented by 2 pilot wells lined up. The first will be in Texas, completed by Q4 with Rife Energy, and the second starting in Q1 with Aero Energy in California. In the midst of the California pilot well, we'll be raising a $3 million seed round. We will hire 3 engineers, mechanical, software, and electrical, and then begin the iterative design and build process for our minimum commercial product. Because we are a distributed energy storage technology, the next major milestone is achieving the remote and collective control of all of these MCPs. Renewal has a powerful team delivering results today. The 3 co-founders are myself, bringing experience as a petroleum engineer with Shell, Stefan Streckfus, whom I met during our time as graduate students at Stanford, and who brings experience as a lead engineer with Burger King commercializing industrial equipment, and Walker Colt, who is a petroleum engineer with degrees from Texas A&M and Rice Business School and 8 years of oil and gas experience. We have also assembled an impressive team of advisors to increase speed and effectiveness. We invite you to have a conversation about investing in Renewal to accomplish our next milestones. Thank you very much.
And thank you, Kemp. Let's turn it over to our attendees for questions. We have Walker Colt also joining Kemp on the Q&A portion. So first question, what is the competitive advantage of your technology over other energy storage technologies?
It's a good question. This table summarizes that in short. Here you've got on the top axis a comparison to technologies with some of the more recognizable brand names below them. But essentially, the one we'd like to emphasize the most is that our environmental benefit. We claim that we are the only net negative energy storage device out there because we can seal up these wells and prevent more methane from leaking than is embodied in the equivalent energy necessary to build our device. That means for every gravity well that's installed, it's having a net negative impact on the amount of CO2 in the atmosphere.
All right. Question from Vincent. How is the energy stored? Is storage of like a transient green energy? How is it restored?
So it's a mechanical device. When the weight is at the top of the well, it's got a bunch of potential energy. It wants to descend down that well. When it comes time to discharge, we control its descent and then use a regenerative winch on surface to convert that potential energy into electrical energy and put it back into the grid.
Next question. What is your revenue model?
The revenue model will be a combination of energy storage revenue streams. So that's the most frequently cited is energy arbitrage, so buy it low, sell it high, as well as a various combination of ancillary services, which is us basically getting paid by the utility or the balancing service to help run the grid. These are frequency regulation, resource adequacy if you're in California, and a handful of others. And what makes Renewal so interesting is that we can combine so many different revenue streams in the same device.
Kemp, what is the useful lifetime of your Renewal?
That's another good question. The timeline that we anticipate for the useful life of any given Renewal is somewhere between 25 to 30 years.
Okay. Question from John Jeffers. How do you handle the environmental risk associated with these legacy wells?
That's a good question. When we go to convert a well, Renewal will handle all liability associated with the damaging of the well that is our fault, that happens during our installation or operation. But the final plug and abandonment liability will stay with the oil and gas company.
Question from Jim Allman. How much energy can be stored per well? Using what weight through what distance?
I wish there was a quick and easy answer to that question. It's mostly it depends, simply because the idle well population is so varied. Wells can be 3,000 feet deep or 15,000 feet deep. They can have 5.5-inch casing or 9-inch casing. But generally, to put bookends on it, we're talking about something like 25 kilowatt hours to up to 200 kilowatt hours per well.
Thomas Henry asks, what is your IP for this technology?
Another good question. Thank you, Thomas. We have 4 patents pending for our technology, and those should be converted sometime early next year.
A question from Derek Adams. Are you assuming all liabilities from the original well owner?
So I think embedded in the question is sort of the idea of who owns the well once we convert it, and the well will stay the property of the operator of record. So if that, company XYZ always owns the well. We just rent the well from them. That rental payment is either something we agree upon or a cut of the energy storage revenue stream. I hope that answers the question.
Hopefully so. Next question from Hani. When you say seal up the well, are you first securing the well, eliminating any sustained annual pressure, replacing in-well jewelry, or are you using as is? And does the well have to be empty, or it can be full of fluid, etc.?
Yeah, really good question. Okay, so for any given well, the average is going to have tubing and a pump jack on it, let's say. To remove that tubing and the pump jack is a zero incremental cost to the oil and gas company. They have to do it eventually. So the agreement thus far is that they prep the well, which means pump jack away, tubing away, and seal it at that lowest reservoir or shallowest reservoir, and then sort of turn it over to us with a well bore full of whatever fluid was in there. And then we flush it out so that we have control over the fluid that this weight is going to be operating within. And then that's the operating profile that we anticipate going forward. So it will be in fluid the whole time.
All right. And then the last question from Ashok. What's the CapEx for retrofitting a well with this storage mechanism?
It's a moving target, and we're working on designing that minimum commercial product, which will be representative of sort of our first capital expenditures for our first products. And we have a pretty good idea of how the economies of scale are going to impact this, but you can estimate something like a couple $100,000 for the capital cost of conversion. And then we hope to come down pretty aggressively into the sub 100,000 range.
Okay, thank you, Kemp and Walker and Stefan. There are additional questions in the chat. Feel free to address those during our break. I want to thank everybody within the House of Dauphine pod. Thank you, Kevin, Liz, Sizway, Gachang, and Kemp. We will now take a brief 2-minute break, and when we come back, we'll hear from Mike Evans. All righty, welcome back, everyone. We'll now hear from our second executive in residence, Mike Evans.
Thank you, Matt. Good afternoon. I have been working with the Rice Alliance startup programs for over 10 years. This has been the most information intensive and content rich yet. My great thanks to all of the content providers. So for the last 12 weeks, I've been working with 4 of the teams and have had the good fortune to get to know the founders and as they have pursued their dreams. These companies range from very early stage to well-developed startups. All are pre-revenue, and 2 of them have received funding. All of them have been really active over the past 12 weeks and have made significant progress during the program. These technologies are very diverse, as you will hear shortly. Here's a brief preview. 3E Nano has developed a revolutionary nano-based thin film that can be used on glass and polycarbonate windows to greatly reduce building heat loads and thus HVAC energy requirements. By the way, too late for now, but polycarbonate windows are also hurricane proof. Moat, located in California, is a system integration technology company using proven components to recycle wood waste to produce and sell hydrogen, store carbon underground, and sell carbon credits. Criterion Energy Partners, founded by 2 Rice MBA graduates, is developing geothermal heat and power projects for energy-intensive industrial sites. Finally, Velex Computing provides a software intelligence platform for advanced analytics and computation that enables more resilient, secure, and sustainable grids. So I think you can see the diversity here. It's been challenging and fun for me to get to know each founder as I gained a better understanding of both their technologies and their business potential. So let's begin. First up is Jason Poon, CEO of Velex Computing.
Quick note, Jason was voted most likely to give you the edge you seek through edge computing. Jason, I can see you and I can see your slides.
Thanks, Matt. Thanks, Mike. Hi, everyone. I'm Jason Poon, the co-founder and CEO of Velex Computing. I'd like to introduce you to Kevin Jackson. He's Director of Enterprise Architecture at a community-owned utility company, and he's responsible for ensuring that the lights don't go out for more than 400,000 people. And of recent events around the country have shown, this isn't a trivial task, and failure to preempt these problems can have tremendous adverse impacts on the lives of his customers. Kevin needs better ways to monitor and control his infrastructure, such as this substation and its transformers. And he wants to be able to proactively detect problems and maintenance issues before they happen. However, all of the existing edge and cloud-based computing solutions he's seen require substantial hardware upgrades for new industrial PCs and connectivity equipment. And all of these require truck roll, CapEx investment, and potential equipment downtime. These are ultimately deal breakers for Kevin. We are here to help people like Kevin with the Velex Acceleration platform. This is a software solution that Kevin installs on his existing on-premise hardware, such as this industrial gateway. It enables 5 to 10x acceleration in the compute performance of his legacy hardware. And because he's using hardware that he already has, there's no CapEx. And because the acceleration platform can be deployed as a no-touch over-the-air software update, there's no need for truck roll or downtime, leading to up to 20% reduction in OpEx. The Velix acceleration platform can be installed on a variety of edge compute hardware and operating systems, including PLCs, data historians, and industrial PCs and gateways. We provide a variety of applications that leverage our unique acceleration technology to enable important functionalities that Kevin wants, such as predictive maintenance, real-time fault and anomaly detection, and on-premise ML model training. Our accelerator technology is based on foundational IP, which has been in development by our founders at Stanford for over 2 years. Velix is currently in the process of obtaining an exclusive licensing agreement with Stanford, which we believe will be in place in 1 to 2 months. Our technology stack is highly differentiated from existing solutions on the market. We provide the best solution for edge applications that require advanced compute performance and low latency. And by doing so, we can provide our customers with the lowest installation and operating costs for their most important application. You may be wondering about some of the other application verticals that our product can be used in. And indeed, our vision for the acceleration platform is to tap into the $700 billion edge computing market. This is a very exciting and growing space, particularly in industrial IoT, smart manufacturing, traffic management, so on and so forth. And these verticals dramatically increase our total addressable market, and we're actively exploring pilots in these areas. In order to capitalize on these growing markets, we have 3 revenue streams. We primarily monetize the accelerator platform as a usage-based SaaS solution, but we also provide turnkey solutions and license our IP to end users and supply chain customers. In terms of traction, we're excited to say that we're currently engaged with 1 pilot with Dynamic, an edge operating system company. And with them, we are aiming to demonstrate a live prototype of our technology with a community-owned utility company in Florida. And in addition, we have 5 additional pilots in our pipeline that we are aiming to start in the next 6 months. Our go-to-market plan consists of first deploying these pilots and field trials with supply chain customers. Then we'll launch on a beachhead market and subsequently scale once we've reached TRL 9 level validation. Also shown here are our anticipated funding rounds and forecasted revenue for the next 5 years. We intend to raise funds in Q2 of 2022, and we're looking to develop relationships with investors today. Of note, we're looking to expand our team, particularly to accelerate our business development and to establish industry connections that can lead to new pilots. And this is the team that's making it happen. Our 2 founders, myself and Pollock Jane, have been leading the development of the core Velix technology for over 2 years and have extensive experience in the industrial IoT and electric utility space. We also have an amazing group of advisors with expertise in business, strategy, and technology from places like Google DeepMind, Stanford, and Aviva. Our team is ready to empower people like Kevin with the tools to make his systems more resilient, secure, and intelligent. We'd love to connect with you if this vision excites you too. Thank you.
Thank you, Jason. We'll now open it up for questions. Remember, you can either type it in the question and answer box or use the raise hand function and I'll unmute you. Jason, maybe you can lead us off with updating us on the status of your IP.
Yes. So as mentioned, our IP is owned by Stanford, and we currently have 2 patents pending that we believe will be fully prosecuted in the next 12 months. And we're currently in the process of establishing an exclusive licensing agreement with the Stanford Office of Technology Licensing, which we believe will be in place in 1 to 2 months.
And then next question, how do you plan on pricing your product?
We plan to price our SaaS product as a usage-based solution. So similar to other cloud-based products where you're charged by the amount of time that you're using the product, we will have a similar model where you're charged based on time, but then also accounting for the complexity of the computation that's being performed. And that will vary depending on the type of hardware that's used. So it will be unique depending on the type of application.
From Hani, Jason, great presentation, exciting space. I'm not entirely clear on your targeted use cases and your scaling roadmap. Why will you need so much funding if yours is a primarily software solution?
Great question. So yes, we are planning. Our initial go-to-market plan is a software solution, and we will require funds in order to build our IP portfolio and also to develop these field trials with our supply chain customers. We have further plans to develop our accelerator technology, which can require further funds. But we do believe that by going with a SaaS solution, that our initial requirements for investment can be lower than if other types of product paths were pursued.
They also asked for clarifying your targeted use cases. If you can address that. And if you did it already, then we'll move on to the next question.
I can touch on that. So yes, we are exploring pilots with, okay, let me back up. So our current pilot is with Dynamic, an edge operating system company. And we think this is a very exciting pilot because Dynamic actually has deployments in multiple verticals. So not only in the utility space, but also in smart manufacturing and in advanced automotive applications. So we're hoping to explore all of these verticals through our pilot with Dynamic and go forward with the one that makes the most sense.
Next question. Eventually, do you think a matched companion hardware acceleration module would be desirable?
Sorry, a matched companion. I understand. Yes, a hardware. Exactly. So this may have been related to an earlier question, but our core IP is actually realizable as both a software and a hardware solution. So with the software solution seen on the left, we can provide 5 to 10x performance acceleration, but by realizing it as a hardware solution, as mentioned in the question, and this could be something like a card or a stick that you can plug into your existing compute hardware, we can actually provide a much higher amount of acceleration, something like 10 to 100x. So as mentioned, we're initially planning to go with the software solution because that lowers the amount of capital that we'll need to get to market. But the hardware solution is potentially on a roadmap, depending on if that's something that our customers want and if the value proposition is there for something like that.
Question from Ashok. Is your IP license from Stanford exclusive to you?
Yes, we are pursuing an exclusive licensing agreement that we believe will be in place in 4 to 8 weeks. So it will be exclusive.
And last question from Bill Kamen. How robust and commercialized is the software currently? Do you have the team in place to scale for production usage?
Yes. So currently our technology is at TRL4, which means it's working in a laboratory environment. With our pilot, we intend to work with Dynamic, who have already deployed production-ready implementations of their operating systems with utility companies. So we intend to leverage that in that they've checked off a lot of the red tape and actually have deployments and relationships with these utility companies. So we do believe that we currently have the team to get this initial pilot up and running. But as discussed, we do hope to expand our team in roughly 6 to 12 months to bring on additional expertise in this relevant edge compute space to help us scale further.
Excellent. Thank you for the questions in the Q&A box. Up next, we'll hear from Criterion Energy Partners. Thank you, Jason.
Thank you.
We'll next hear from Danny Ray with Criterion Energy Partners. Danny was voted most likely to be labeled the strong silent type and also most likely to meet up and discuss business over a beer.
Great, thanks, Matt. You can have clean, reliable, always-on energy offering the same environmental benefits as wind and solar without dependency on the weather. And there's an industry with hundreds of billions of dollars in technology and a workforce already developed and perfectly positioned to unlock this resource. Today, I will tell you how Criterion plans to deploy next-generation geothermal energy. Our customers are sustainability directors, operations managers, and infrastructure engineers. They are motivated to reduce emissions and improve reliability of their high energy consuming facilities. These experts are responsible for critical infrastructure and large manufacturing, and their executives have set aggressive net zero goals to keep their brand image clean. Today, customers are unable to meet their sustainability goals and reliability needs. Reducing emissions has become a top priority. Grid reliability problems have increased operating costs on the order of millions of dollars, and these issues are only forecasted to get worse. Criterion geothermal systems are co-located with facilities to replace fossil fuels and costly grid dependency from behind the meter. The solution is designed to serve high energy consumers and offers both always-on electricity on a microgrid as well as direct heating and cooling like piped steam or chilled water. It can even sell energy back to the grid. This solution puts the customer in control of their emissions and energy supply. The key is highly engineered wells and reservoirs below ground. Think horizontal oil and gas wells for geothermal. Each completed zone is designed to deliver the highest megawatt output per well for the lowest cost. Our industry-leading design sets us apart from the competition. Criterion's goal is to deploy 1,000 megawatts and eliminate 6 million tons of CO2 per year by 2040. That's equivalent to removing 1.2 million cars from the road every year. And because our systems are mostly underground, the land footprint is 10 times lower than other renewables. Reducing well costs and increasing output by cross-pollinating technology from oil and gas is the key to unlocking geothermal energy in new ways. Proven technology can be deployed today to deliver geothermal at a lower cost than wind and solar with storage and competitive with gas combined cycle. The story only improves with the cost of carbon. Our technology roadmap will take historical costs of $75 to $45 and will allow us to deploy geothermal energy in new places around the globe. This is accomplished by applying a proven strategy our team has executed many times before to maximize recovery and minimize well costs. It is a formula for geothermal energy at scale. Development projects can be financed off balance sheet, minimizing our capital outlay for the customer. Our primary source of earnings will come from development fees and retained project equity, then operations, maintenance, and service contracts. Our team has completed initial screening on multiple sites and selected one location on the Texas Gulf Coast for our 5 megawatt pilot in 2022. Criterion is focused on distribution centers and chemical facilities as initial beachhead customers. Once a Criterion geothermal system is installed, facilities are protected from blackouts and can even deliver energy back to the grid. Operating costs are low and don't vary with commodity price. Today, we are raising a seed round, forming strategic partnerships, and advancing our pilot. Over the next 12 months, we will expand our already strong portfolio of prospects, iterate on our designs, conduct feasibility studies, and execute our pilot. Our leadership team has a proven track record with Fortune 500 companies and is applying the same best-in-class execution from oil and gas to next-generation geothermal. Criterion has formed a powerful industry advisory team with expertise across the geothermal and oil and gas industries. The goal is to raise $3 million in funding to fast-track the deployment of Criterion geothermal systems. Won't you join us and be a part of the solution? Thank you. Please reach out, and we look forward to answering questions.
Great talk, Danny. Question from John. You touched on the technology being differentiated from others. How so? What stands you out from other geothermal energy companies?
So our team has spent a lot of time developing a technology roadmap to identify the key technologies in drilling, completion design, and reservoir management in order to bring the costs down from where it is today to where it needs to be competitive in markets and new geographies. So there's a lot of different technologies that are required to do that. And our team has experience deploying this strategy in drilling thousands of wells, drilling and completing thousands of wells, and executing this same plan in oil and gas. And we've identified the roadmap to do that for geothermal.
Joining Danny in the Q&A is Sean Marshall. Welcome, Sean. Next question. What geographical constraints are present for this geothermal technology? Which states are the targets for additional rollouts?
So you can see on the screen here, we've got a heat map and effectively shows the temperature gradient. There's other things that are required that are favorable for geothermal energy. It's not just the resource, but also the off-taker and the market place that kind of drives the value proposition here. So we've identified Texas as a great location for our first pilot. We're also working on pilots in California, and we have existing leases in the state of Utah on the West Coast. But as we bring the cost of geothermal energy down and improve the recoveries, the flow rate and the temperature are the two main parameters needed to generate energy. So as we increase the flow rate with our design and the deployment of our technology, we'll be able to take this solution to areas where the temperature gradient isn't as high and where geothermal energy just hasn't been economical in the past.
Question from Andrew. Are you planning on closed loop or open loop? What's proprietary to Criterion?
So our design is a modified EGS, enhanced geothermal system, which effectively is utilizing both a producer and an injector pair. and moving fluid through the reservoir system to extract the maximum amount of heat. So, one of the advantages of this design is that high heat capacity can be extracted from the reservoir system, existing natural systems that help support the energy flow into the wells can be harnessed in a way that a lot of closed loop systems can't do. So that's really what helps us deliver the highest output for the lowest cost.
Along the same line of questioning, what IP, if any, do you own? So
I mentioned the technology roadmap, and there's 20 or so technologies that we're highly focused on. Some of those we're developing internally. We do not have patents currently, but potentially we'll be working towards those in certain areas in the future. We're also working with strategic partners in building an industry advisory team to develop technologies and deploy those technologies. And then we're doing a tremendous amount of research as well on areas like supercritical CO2 and thermal energy storage and CO2 sequestration with these systems to take advantage of those opportunities as they become available in the future.
Question from John Jeffers. What are the key risks and uncertainties associated with the technical performance of your solution? In other words, the ability to deliver the expected power for the investment made.
Yeah, great question. So the key really is in connecting the permeability pathways, the conductivity, the connectivity of between the two wells is absolutely critical to delivering the energy that's needed. And that's really what our team has focused on and where our expertise lies. So understanding how to drill the wells, utilizing directional drilling, multi-stage completions, completing the well in a cost-effective way, but one that maximizes the recovery is a lot harder to do than it might seem. And so that's the completion design, the well design. That's really where our team is highly focused, and the key factor in determining what that output's going to be and what the return on the capital is going to be.
Thank you, Dave. That's all the time we have for questions.
When you're able.
Great. Thanks, Matt. Thank you all.
We'll now turn to Matt Kennedy with Moat. Mac was voted most responsive on Slack and our emoji hero.
That's a huge honor. Thank you so much, Matt. Appreciate it. So I want to try something. Everybody, please close your eyes. All right. Are they closed? All right, now open. Today is your lucky day. You are a construction manager and you just finished a big project. Where are you going to take all these piles of wood waste on your site? You truck it to a landfill and pay a lot of money. Now you're a farmer and have mountains of branches and nutshells at the end of a long season. In California, it's now illegal to burn that wood. So you too are going to fork over an exorbitant amount of money to your local landfill. And if you're a forester, well, there's no place to take the tinderbox piled up all over the forest floor in front of you. The United States generates over 500 million tons of wood waste every year. And our company Moat recycles wood waste to produce the cheapest hydrogen. Businesses today are desperately seeking to remove their carbon emissions and to switch to renewable hydrogen. But today's solutions are virtually pilot scale and are prohibitively expensive. To hit net zero, we have to reduce emissions to zero and then remove billions of tons of carbon every year. And so Moat is repurposing legacy equipment to provide companies the cheapest renewable hydrogen. We partner with oil and gas companies to then permanently store the atmospheric carbon from wood waste into geologic formations underground. Our beachhead market is selling hydrogen as a transportation fuel in California, making use of California's carbon credits and the federal carbon capture tax credit. In the long run, we'll sell hydrogen in two other main markets and sell carbon credits mostly to the private sector. Our core value proposition is that hydrogen is just upside to our carbon credit business. The value of carbon credits can be cut in half twice, and we're still profitable. There are over 3 billion tons of wood waste generated globally, showing the enormous scale of this opportunity. Our company's strategy doesn't rely on technology risk, and our first plant is commercial scale and profitable from the start. Major oil companies agree that renewable hydrogen and carbon credits are both trillion-dollar market opportunities, And our company Moat is positioned to lead the way in these rapidly emerging industries. Our hydrogen competition is the use of electricity to split H2 from H2O, which does not qualify for carbon credits, making it always more expensive than Moat's carbon negative process. And compared to other ways of getting carbon credits, Moat has the lowest cost per ton of carbon and the highest scalability across the globe. We get revenue from licensing our technology to local developers around the world. We are cash flow positive at the time of project finance and have a waterfall ownership stake alongside cash equity project investors. This gives us a significant share of hydrogen and carbon credit revenues. We expect carbon credits to not be as valuable as they are today, but our financial models show that our economics are resilient to virtually any market shifts. We just kicked off engineering for our first plant design. In 18 months, we'll have steel in the ground for our first hydrogen production facility in California's Central Valley. We're getting ready to file 3 key system integration patents, and we're using our corporate equity to lock in the sites, studies, offtake, and feedstock necessary to secure financing for our initial pipeline of projects. We have a suite of skills that's really hard to find under one roof. We have decades of experience building and operating large gasification plants, buying millions of tons of wood waste per year, buying and selling hydrogen as a transportation fuel, building and operating hydrogen fuel stations, and inventing transformative system integration technologies like what started as carbon engineering. We're raising $2 million, and of that, already have $1 million committed. With our seed round, we can prove bankability for our first project. We're looking for more investors and advisors with experience building energy projects. I really appreciate your time and look forward to your questions. Thank you.
Thank you, Mac. First question from Q&A. Is your revenue model solely dependent on policy credits? What if these have a sunset or in geographies that don't have these credits?
Awesome. Thank you for your question. So in the long run, most of the demand for carbon removal is being driven by the private sector. So we're already seeing it today with innovative companies like Microsoft, Shopify, and Stripe, and Google, who are doing really large scale carbon removal purchases. So these companies are planning for the long term where there's very early stage market for carbon removal. So ultimately that's being driven by the private sector. So, ultimately there's a cost for removing CO2, and we have ultimately the kind of the most competitive solution to remove, billions of tons of CO2 at the lowest cost with the greatest kind of social acceptability.
Thank you, Pradeep, for the question. Next question from John Jeffers. Does your process on net produce or consume thermal energy to produce hydrogen? If it consumes, what is the source? And if it produces, do you recover and use this energy?
Awesome. Thank you for your question. Our process is exothermic, so the energy for our process is provided by the wood waste itself. If our customers are looking for liquid hydrogen, then we'll have to buy a little bit of renewable electricity to power the liquefier. But aside from that, we're not exporting energy to the grid, but it's enough to kind of power the process.
Next question from Zanu. Can you comment on the process and technology from biomass or to convert biomass to hydrogen carbon? Is it pyrolysis?
Yeah, so instead of pyrolysis, which usually works well at a small scale, we decided to go with gasification. There's already TRL9. There's already a TRL9 biomass gasifier out there that we're using that's integrating into our system. Works better for carbon capture and larger scale. So pyrolysis works well at small scale, but we're really kind of focusing on the long-term vision here.
Question from Bill Boyle. Mac, what is the capital cost of a plant?
Yeah, so we're currently developing a demonstration facility. We don't really need to do like a pilot scale since this is all TRL9 technology. So we're going straight to a demonstration scale, which is over $100 million. So we're utilizing project finance, the federal 45Q tax credit. There's kind of 3 parts of the capital stack, which is, debt, tax equity, and cash equity. So project finance for building the demonstration plant.
Next question from Tina. What is the cost of hydrogen generated by your process?
So in terms of the cost of hydrogen, the hydrogen for us is kind of upside to this carbon removal business. So we ultimately have a lot of flexibility in terms of our pricing. So the cost for us is, very minimal to where, we're able to kind of outcompete other options. We're going to be selling the hydrogen at market price. But as that market price keeps going down over the next couple of decades, we have a long-term advantage of being able to outprice our competitors.
Follow-up question from Zanub. Are there any pilot projects completed yet?
Yeah, so the pilot scale gasifier has been operating for several decades. The full commercial scale, which is 3 times bigger than what we're building, has been commercially operating for over 15 years now, has been using dozens of feedstocks. So the demonstration is the system integration, which is generally understood. There's a state-of-the-art understanding of how to connect, these different components like, air separation unit and water gas shift. It's generally understood and been done for decades. This is the first time that this exact process flow has been put together. So that's novel. And then our system integration technologies and how we're increasing the energy efficiency and carbon intensity is the novel part. But, there's kind of a balance of not over-engineering the first project. So that's kind of a consideration as we're getting into the more detailed engineering.
Last question from Wyatt. What is Moat's biggest moat against new entrants?
Yeah, so we realized early on that we didn't need to create any new widgets for what we're doing. So we decided, at the beginning that we were going to be a system integration technology company, and that the most durable value we can provide is leveraging our expertise in process optimization in terms of, taking advantage of this huge opportunity of being the first people to commercialize this pathway, and there being enormous, fresh powder for us to ski down in terms of developing out the IP before everyone else. And so we have a huge leg up now. And as we're now entering the more detailed engineering, a lot more technologies are becoming apparent to us in terms of how we're connecting these pieces together. So
excellent. We're going to move on to our next team. Appreciate it, Mac and Joshua.
Thank you.
Our last House of Evan startup is 3E Nano. We will hear from Steve Ferrero. Steve was voted most likely to take the idiom, "The eyes are the windows of the soul," too literally.
All right, very good. Thank you. Hi, everybody. I'm Steve Ferrero, CEO of 3E Nano. And 3E Nano is all about bringing solar control to polymer-based architectural applications. I worked for 34 years in the polymer industry and discovered that 3E Nano's solution was 10 times better than anything that exists in the market today. We provide a path for improved energy efficiency and decarbonization of infrastructure with our solar and energy control coatings. So polymers are used successfully in northern cooler climates, but due to lack of solar control, they can't be specified in warmer climate zones. The revolution that we're bringing to the market is to enable polymer materials to have solar control, which opens up billions of dollars of revenue to our customers who can now sell in expanded geographies around the globe. We've invented a transparent heat filter. It filters heat from light, and it allows the light to pass through, but reflects the heat. The coating gives you a natural view of the world. It's high light transmission. It's always on. It needs no electricity, unlike a dynamic window, which uses electricity and goes dark to block energy. In that regard, we're better and less expensive than those systems. Dynamic windows are also absorptive and not reflective, making them less energy efficient. So when we look at a matrix of light transmission and solar performance, and you consider the better insulation value of polymers, we are in the high category, making us standing out from the competitive systems. Compared to laminated glass systems, the polymer-based systems are 4 times lighter. They require 3 times less steel and concrete and to support the structure. Films can also be considered a competitor, but they are difficult to handle for consumers. They're absorptive, and they are not made for polymers, and they do little to address the insulation problem. We are focusing on transparent architectural polymer-based applications. These applications already exist. However, with solar energy control, these applications can be found in applications all over the world, in airports, hotels, malls, restaurants, train stations, in both new and retrofit in commercial and residential building applications. So our business model is that we will put our coating on our B2B customers' polymers, giving them new solar control capability. Now armed with this new capability, they can sell their upgraded products in all climate zones with no restrictions. Now they can sell applications both in Denmark, but also in Dallas and in Denver. We are pre-revenue, but it's our goal to capture 1% of the global architectural market, which will make us $1 billion company. There are huge opportunities for our solution, and we're looking for strategic partners operating in the built environment and energy efficiency space. We're raising $800,000 of equity for milestone 1 of a 3-year commercialization project with a Canadian government agency working on reducing greenhouse gas emissions. The milestone 1 funding will come with an $800,000 non-dilutive grant. And overall, the 3-year project will offer $4.7 million in non-dilutive funding, which will enable us to be fully commercialized by the end of the project. We are a diverse and cohesive team of 8 with polymer, plasmonic, and photonics experience. The co-founders have prior startup experience as well as deep business acumen at the senior VP level of Fortune 100 companies. I have in-depth experience in creating innovative technologies for polymer applications to expand markets and create value. We'd be excited to speak with you if you can contribute to or connect us with partners to test our energy efficiency and decarbonization potentials. I ask you to join us in disrupting the architectural space with the disruptive idea of using nanotechnology and polymers to fight climate change. Thank you.
Thank you, Steve. We have a question in chat from Rob Tucci. Does your coating interfere with radio waves?
There are patternings that can be done on the coating to allow it to transmit radio waves, including 5G signals. And actually the coating can be used as a transmitter for 5G signals as well.
Okay, next question. What's your next milestone and how much do you need to raise to get there?
The next milestone is that we will prepare roll-to-roll production samples on commercial equipment and provide those samples to our customer. And basically for 8 months of the first milestone, we'll be raising $1.6 million to support that and the work of the company, half of which will be non-dilutive.
Great. And then next question. So you're suggesting a conversion of windows from glass to polymer. Is that correct?
Partially correct. There's polymer-based applications already used in the market. And however, a major glass to polycarbonate conversion happened in the world in the area of automotive headlamps, where all headlamps used to be glass. And in 1984, the first polymeric headlamp, PC headlamp, came into existence. And in less than 10 years, the entire world switched over to polymeric headlamps. And that's still the dominant technology today. We actually have a slide on that. It only took 10 years to convert over globally to this new material because of the advantages.
Question from Tina with GC Ventures America. How do customers apply the coating? Any CapEx requirement?
So the coating will be produced at people's plants that make the substrates, and it'll be laminated online. So we'll supply rolls of film with our nano coating on it, maybe 2 kilometers long. And while they're manufacturing the substrates, whether it's acrylic or polycarbonate, they will integrate it in their line, in their plant while they're making the substrates. And that's how we incorporate the technology into their products.
Kind of along the same lines, can the product be applied in situ? Or in other words, can it be applied to existing buildings, windows, et cetera?
Well, the window insert concept that you see here, there's already existing rigid applications, but they don't have solar energy control, as most of these applications don't. So our business model is really to work with substrates that already go into these type of applications. And in this case, it would create turn a single pane window into a double pane window, but also with a low E coating, so that it can be a DIY retrofit, say for an apartment, where you could turn your normal leaky, energy inefficient window into a low E, high energy efficient, high thermal barrier window opening.
And then last question, there's actually two, but they're similar. So I'm going to read both.
All right.
What is the expected degradation over the lifetime? And another way of asking, are there any similar problems to the polycarbonate headlamps where they yellow and haze over time?
Yes, that's an issue that was created due to the specification of the lifetime of the headlamps that they designed for a 10-year lifespan. We are designing for a 20 to 30-year lifespan. And another thing is that the coating we have is UV blocking, so it protects the polymer from seeing UV, and it also rejects heat, so it keeps heat out of the polymers. And those two things will extend the life of the substrate.
Okay, for those questions that weren't addressed, Steve, please address them in the Q&A box, or please, if you're an attendee, reach out to Steve and 3E Nano.
Okay, very good. Thank you.
Now we're going to transition to a brief 2-minute break. But first, I want to thank Mike, Jason, Danny, Mac, and Steve. And when we come back, we'll hear from Caroline Walkman. All right, welcome back. Let us get Caroline spotlighted. Thank you so much for rejoining us. Caroline is our executive in residence. Caroline, we all have your attention. Please go ahead.
Great, thanks, Matt. So I'm thrilled to round out the afternoon by introducing the 4 companies that I've coached through the Accelerator. These teams have shown perseverance and grit to even start a company in a pandemic, and resilience to keep adapting, pivoting, and pushing forward. And it's really been such a pleasure to watch their growth over the summer, and I know that good things are in store for them in the future. And so that, let me introduce the companies. So Randy Rutherford is here to share how Cannon Energy turns industrial waste heat into profitable emission-free energy. Randy has decades of experience in clean energy business development and has been driving customer interactions at Cannon since joining the company at its founding early last year. He'll share how Cannon is using existing technologies to deliver innovative decarbonization projects for industrial customers. We'll hear from Clint Dietz, who's the CEO and driving force behind Hydrodyne Catalytics. It's a company that's developed a novel technology to reduce methane emissions and generate power. Clint will soon be testing the technology in a field trial at remote natural gas well sites in Western Canada. And today, Clint will share how Hydrodyne can save customers money, eliminate emissions, and provide a safe source of power. We'll hear from Ali Farzbud, a PhD mechanical engineer and a serial entrepreneur who co-founded CivicCell Technologies. Today, he'll share his solution for providing power to instrumentation and sensors by utilizing waste heat in industrial settings. This technology has applications across multiple parts of the energy industry. And leading off the session is Gulati, who's the founder of Nasadia. Not only is he an undergraduate engineering major at the University of Illinois, but he's also leading a team that's optimizing a technology to produce cost-effective, carbon-free hydrogen by using overgeneration from renewable power plants. So please welcoming these companies, and then over to you, Gulati.
Gulati, before you get started, your award. Gulati was our most traveled presenter this summer and was voted most likely to have Zoom be disrupted by a monsoon. It shouldn't be a problem now that you're back in the States.
Hi everyone, I'm Chaitanya Gulati, the founder of Nasadia. Combating climate change requires zero carbon fuels, and hydrogen can be one. However, zero carbon hydrogen is too expensive to produce, and the current hydrogen generation contributes 800 million tons of carbon dioxide, which is 2% of global emissions. We at Nasadia will reduce the cost of zero carbon hydrogen to $1.5 per kilogram, which is half the current cost. So this is a big opportunity. Even if all the current hydrogen production is made zero carbon by investing in carbon capture and sequestration, the world will still need 300 million tons more by 2040. These 300 million tons represent a $600 billion opportunity for us by 2040. I believe the best source of this additional hydrogen will be electrolysis from renewable energy. This will require major technological advances, and we at Nasadia plan to achieve this with our AEM electrolysis, which stands for anion exchange membrane. Our solution will get the cost down to $1.5 per kilogram by focusing on improvements in 3 key areas. We have plans to lower voltage drop and thereby improve the electrical efficiency by 40%. Secondly, we will increase membrane capacity by optimizing composition and a manufacturing process to lower capital costs by 20%. And lastly, whichever AEM technology is in the forefront, and the planet for it to be us, will benefit from the manufacturing learning curve to lower cost. So we have a sense of urgency to our work. Let me show you why our AEM electrolysis will be the leader. The key competitive factor is the cost of the zero carbon hydrogen. And our cost at $1.5 per kilogram will be well below the 2.5 for the competitive technologies. The latest technology for electrolysis is AEM. This is what Nasadya is developing. It has many advantages, including cheap raw materials. The other and primary kind of electrolysis is PEM, which stands for proton exchange membrane. It cost only drops down to 2.5 as it is a much more mature technology. For natural gas plus CCS processes, the improvement potential has been maximized. So the cost is likely to rise due to the forecast increase in the price of natural gas. Do we really want to be making hydrogen by burning fossil fuels and then sequestering the carbon dioxide instead of just making it carbon-free from the beginning? Our entry market is where carbon emissions cost the most. California has CO2 reduction requirements, and the value of carbon credits are currently at $200 per ton. Most of the existing 4 million tons of H2 will have CCS added. We are specifically targeting refiners that can't add CCS because it's too difficult to sequester the CO2. Also refiners that need additional hydrogen because they have to face the whole cost of new zero carbon hydrogen. We will be project developers and hydrogen providers, whereby we receive a fee for providing the technology and operating the plant. For a plant to be profitable, we need to acquire low cost electricity, for which we will offer a solution to reduce curtailment for renewable power plants. Our typical electrolyzer plant will produce 50,000 tons per annum of zero carbon hydrogen with a capital cost of $45 million. Our financial forecast begins with an $8 million investment in our product development in 4 stages. The first stage will be lab scale testing, costing $500,000, funded by federal grants. Our first commercial Nasadya AEM electrolyzer will start up in 2026 at a cost of $45 million, giving us a fee of $5.3 million a year. This gives us a cash flow break even by 2028. Then a second commercial unit will start up in 2029. To make this happen, here is a starting team, which we would need to grow quickly as we raise funding. I'm the CEO and have experience leading the Nasadya team since 2018 and recruiting talented individuals to the team, such as Nate, for his experience with electrical equipment. He's currently getting his electrical engineering degree, and Vic for his experience with energy policy and finance. We are early on and would really appreciate your help connecting me with the following: California refiners, wind and solar electricity providers, California and other emission regulators, and lastly, federal grant experts. I look forward to your questions and suggestions during the following Q&A. I welcome your leads during the networking events. Thank you.
Thank you, Gulati. We'll now open it up for questions. First from Tina with GC Ventures America. Can you explain your IP and differentiation from other players in AEL?
Definitely. So in our IP, the key area we're focusing on is something that we've already optimized is the compression system, and that is what we're filing our provisional patent in. Apart from that, what really differentiates us from the other AM electrolyzer companies is that our focus on the electrical efficiency and the durability of the system to reduce the capex and the long-term operations of the system, while most of the current AEM companies are mostly focused on the material science stuff and the materials that go into the membrane. And that's something we're not trying to focus on. We're focusing on the electrical efficiency as we see potential price reductions through that.
Great. And next question, how much money do you need to advance this to a development level where you'll be ready for a pilot?
Definitely. To get to a pilot, which is like a demo plant, we would need $8 million. And for the first half of that, for the first phase of that, which is going to be the lab scale testing, we would need $500,000.
Okay. Just a quick reminder, you can put your questions in the Q&A box or raise your hand and I'll unmute you. From John Jeffers, from a macro perspective, how do constraints on the rate of growth of renewable electricity production and the competing demand for replacing existing uses of electricity with zero carbon sources potentially constrain your ability to scale up in a market like California?
Definitely. That's, I think, a really good question and fits in really well with our business model where we're trying to take in curtailed energy from renewable power plants. Looking at the projections in California and how the market is set up and how with their current carbon reduction targets and the rate at which renewable power plants are being built there, we aren't really worried about offtake or having enough electrolyzers or having enough renewable independent power producers to supply the cheap energy that we would need.
Great. Next question from Farouk. The curtailments from excess renewable generation can be solved and mitigated by storage. What is your plan B for the electricity source? And what is the
Definitely.
expected cost of production in this case?
So actually, in the conversations we've had with most of these power producers, they aren't really that keen on storage at their own location because it has a lot of issues with congestion when they have to ship it off during peak consumption hours, which is when ideally they would want to use a storage, right? So that is why a solution like ours is what they're more welcoming towards rather than a conventional storage at their location.
Thank you, Gulati. Next question from Jim Allman. What's your advantage over commercial alkaline water electrolysis?
So that's a really good question. So AEM essentially is a modified version of alkaline. So in terms of advantage, the biggest thing is that our core technology is building off top of already like the state-of-the-art alkaline producers. So that's actually something we aren't really worried about because we are initially building on top of the state-of-the-art in that space.
Question in chat. Do you build your own electrolyzer or purchase from a third-party supplier?
I think that's a really good question. Our plans right now is going to be looking at our like business model and how we're setting things up with one big plant. Our goal would be to get it manufactured having through partnerships with EPCs and other manufacturing players. But the goal, would be to get it manufactured.
Okay, there's no further questions. We'll move on to our next speaker. Thank you, Gulati.
Thank you.
Up next, we'll hear from Ali Farzbad with Sept Cell Technologies. Ali earned our Early Bird Award and was voted most likely to take a meeting at 6 a.m. with Caroline.
Hi, everyone. My name is Ali Farzbad, and I'm CEO, co-founder of Sept Cell Technologies. Our goal is to harness waste heat through our clean technology. Whether you're using or generating electricity, on average, you're losing 60% of that through heat. Petroleum industry has the biggest share, and that brings up the waste recovery market around $55 billion. We all know energy demand is increasing, and it is critical to look at different methods such as recovery for supplying that demand. Ironically, in the places that they create energy commodities, there is a huge and significant demand for electrical power due to ESG and electrification. That's where we come in. We harvest that waste heat to convert it to electricity, and we store it in the same module using our clean technology. The main component of our technology is ionic liquids, which are applicable to different temperature ranges, and they are synthesizable, meaning they can easily get scaled up and much more cost-effective compared to their semiconductor counterparts. This platform technology has been developed by me 3 years ago in my PhD studies. University of Texas at Arlington owned the patent, and we have the exclusive right to this patent. This patent covers the power generation in low power, medium power, and high power schemes. Obviously, looking at different verticals to commercialize this technology, we did our customer discovery, and we realized that a passive power generator, which utilizes the waste heat in industrial setting and provide power for IoTs, is the best featured market. Currently, majority of the sensors are using battery, and they require to get changed every 3 to 6 months. Set aside the cost of that battery, there is 15 minutes of man-hour for changing each battery. If you don't believe that, try next time when you are changing a battery of your remote. What we do, we retrofit our devices around that waste heat around the source, and we harvest that waste heat that you're already using and provide it for recharging your batteries or directly to your sensor. That enable a faster sensor rate if you need to, and enable new capabilities in subsea applications. Our business model is direct sale to oil and gas and suppliers at the beginning. And while we are increasing our share in that market, we want to utilize our high efficiency in low temperature waste heat recovery and enter an emerging market, which is waste heat recovery from data centers and blockchain. While we are doing that, we already partner up with UTA, University of Texas at Arlington, to do federal grants and contracts with defense agencies. With reaching our technological milestone, we'll be able to license our technology to battery electric vehicle manufacturer for harvesting the heat base coming from their battery. Our competitive landscape in terms of non-moving waste heat recovery market, we beat all the other competitors in regard to cost because we are using a synthesizable material compared to a mining semiconductor, which has a very high carbon intensity for production. And also because we replace that solid state with a liquid material, we increase our power per weight ratio significantly, making us more appealing for transportation and space applications. Our team is including me, Dr. Poon, who has extensive experience and knowledge in this field. And we are also having Jack, who is a serial entrepreneur and has experience in manufacturing companies. We are benefiting from advisors ranging from former vice presidents of BP to Los Alamos Scientist Lab and faculty fellow at Aerovis Research Lab. Right now, we are at TRL4. We are raising our seed round to build our pilot product and have it deployed with the help of IoT companies. And we're anticipating to have our seed round by December 2022 and having our product launched by August 2023. We believe and predicted that we will be break even 4 years after our completion of seed round. With that, I'll ask seed investors and anyone who has expertise in IoT operation, come join our company and let's power the next generation of IoTs.
Thank you, Ali. We'll now open it up for questions. We have our first from Raj. Isn't Everactive your competitor as well, or do you see them differently?
We see them differently because our operation is mainly harvesting waste heat, which is you're already losing. So it has a carbon negative basically generation built into it, which we believe that later on can come into other calculations in terms of offset cycle analysis.
Next question from Vincent. How much will your cell weigh?
Sorry, I didn't get the question, if you can.
How much will your cell weigh?
Oh, so the performance of the cell is basically rely on two main components. One is the area of the cell, which we applied on. I mean, basically the heat source is being applied on, and then the temperature difference of it, right? So it depends on the efficiency required and the power required. We can design that to provide the power requirement for each sensor. So right now, we believe that for 1 watt sensor, it comes around 400 grams. I mean, right now we are using 3D printing material, and that's just an estimation. But that's something that we want to investigate as we do life cycle studies in pilot run.
Thank you for the question. Another one from Jim. How do you convert the waste heat to electricity?
This is a totally different paradigm regarding the semiconductor. Basically, we have this ionic liquid which we tweak with adding nanoparticles into it. We create a nano fluid, and when this heat goes through these cells, basically this ionic liquid create a charge difference by having a different mobility because of that heat going through it. So we harvest them through either adding redox couple or creating a surface enhancement at the surface of the electrode, basically like a supercapacitor. But it is getting charged as the heat goes through, and as that ionic liquid create that voltage difference inside of the cell.
Question from Ashok. Can you comment on the cost of your product when scaled up?
So it's a very interesting question, because one of the main advantages that we have is that because we are a synthesizable material, as we scaled up, the main component of our devices, cost will reduce significantly because we can go to a higher synthesis scale and then have a much higher production rate. So we believe that as we go forward, as we integrate more into market, we can reduce the cost of our devices significantly.
Can you comment on the competitive advantage compared to the organic ranking cycle?
So we are not directly competing with organic ranking cycle. Organic ranking cycle is mainly used for high temperature application, which then they have the 23% efficiency. We have 12% efficiencies, but we don't go after that market. We are mainly going after recovering waste heat in a much portable way and much less initial cost to provide power for sensors. But we do believe with reaching our second milestone, we will be able to reach 23% efficiency at high temperature, which then in that case, the difference between us and organic ranking cycle is that we don't have any moving parts. So our life cycle cost is much less than organic ranking cycle. Our lifetime is over 20 years, which I bet no organic ranking cycle can run that long and have no cost.
A follow-up question. What is the efficiency and how does it compare to piezoelectric generators?
So piezoelectric generators are mainly converting the vibration to electricity. We are converting waste heat to electricity. So the conversion is basically then is more solid. Vibration conversion to electricity. Ours is heat conversion to electricity. We don't need any vibration. We're just looking at any type of steam injection, boiler, compressor, which are either they're running at very high temperature or they're in contact with even environment. We just come in between them and then start harvesting the heat waste that they're losing.
Last question from John Jeffers. What is your approximate cost per watt?
We did some studies. It's $100 per watt, and that's not completely accurate, but based on, we see that a $500 device can provide around 5 watt power if we have a good heat source. And it's something that it needs depend on that. So it depends on the temperature of the heat source and the environment, but it's on average, it's around that number.
Can you say that number again?
We are
one more time?
predicting $100 watts, but that kind of comes to play if you have $500 device, which provides 5 watt power.
Well, Ollie, thank you so much. We're going to go ahead and move on to our next startup. We'll now turn to Clint Dietz with Hydrodyne Catalytics. Clint was our cohort's crooner and was voted most likely to break out in song. His karaoke go-to is a traditional Korean song, Omaya Nunaya.
Great, thanks a lot, Matt. Doesn't it seem to you like GHG emissions is at the top of the agenda these days? Just to be compliant, Western Canadian gas producers will spend $7 billion on methane emissions reduction at over 350,000 wells. By using Hydrodyne in only 5% of these wells, producers could save $300 million. This is why Hydrodyne matters. Hello, my name is Clint Dietz, CEO of Hydrodyne. In the current system, raw natural gas is burned in a catalytic heater. It is used as a pneumatic source. It's costly and it emits methane. This system doesn't meet today's regulatory requirements, making the market ready for change. Hydrodyne has a solution. We remove the current catalytic heater and we replace it with our technology that is easily integrated. In our system, hydrogen peroxide passes over a catalyst to produce steam that we convert to heat. A fuel cell provides up to 1 kilowatt of power to run the electrics. We have patents pending in Canada and the US and trade secrets for our catalyst and our fuel cell. This 3D model shows how the Hydrodyne system fits into a separator shed. Feedback from Tourmaline confirms that our system materially lowers OpEx and CapEx. The commercial unit will be about the same size of a current catalytic heater. Field trial results are better than expected. As we retrofit out existing sheds or new sheds, our system gives a full suite of benefits. But on the other hand, WestJet's unit still burns raw natural gas and emits greenhouse gases, and it's 4 times higher cost than our system. We're finishing a field trial with our beta prototype. Optimization is complete for BP 2.0. We've conducted a site tour with Aerovis, and as a result, we now have a contract with Aerovis. These trials will lead us to our first commercial sales in Q1 2022. Although our chosen target market is 460 million, the Hydrodyne system is a platform technology with a global market of 25 billion. Our business model is a simple B2B direct sales model where we use contract manufacturing and our lead investors' sales channels to sell directly to customers. This is sustained by multiple recurring revenue streams, as you can see here, with the upfront sale of the system and the catalyst, and then ongoing multiple recurring revenue streams from the chemical, the transport, installation and commissioning and maintenance. Hydrodyne expects to grow from 2.5 million in 2022 to 38 million in 2027, achieving profitability in year 3. We'll do this by focusing on the Western Canadian oil and gas market and then expand into the US market. In fact, we are actually holding current discussions with Southwestern Energy. Our ask is $500,000. This will give us a 1-year runway to fully commercialize. We'll methodically stand up a marketing and sales team, and that will also include customer success field engineers. We are a get her done type of leadership team, qualified by over 100 years of experience in the oil and gas market. Thank you. Hydrodyne, the only complete solution, 0 emissions, lower CapEx, greater safety.
Thank you so much, Clint. Let us open up the Q&A portion. First question, how much does fuel gas contribute to methane emissions at the pump?
So this is an application where we work at remote natural gas well sites. And so fuel gas, and we know from
earlier discussions today from Liz O'Connell at Aerolytics that, fugitive emissions from pneumatic sources, venting and combustion accounts for a very large portion of methane emissions in Western Canada and certainly throughout the US.
Another question, you mentioned that this can be used generally as heating. What other applications are you thinking about moving to next?
Yeah, super. So it's a 3-in-1 solution where we provide heat, power, and a pneumatic source. So the applications are actually quite varied. We know for sure that there's a wastewater application, a wastewater treatment application for municipalities, sewage treatment, and for pulp and paper. We also know that this has application in hydroponics, aquaponics, and we've even found an application in defense.
Excellent. Question from Jim Allman. As the peroxide must be delivered regularly, why shouldn't the customer just buy diesel, for example, instead for heat and electricity?
Yeah, for sure. So what we found with our particular technology is the economics work very much in favor of the client. So first off, hydrogen peroxide has an exceptionally low environmental footprint, even at the producer. This is a zero emissions technology, which not only is a lower CapEx and OpEx, but allows the producer to capture offset carbon credits, which is a very significant benefit for them.
Okay, one more question. The end of the presentation mentioned greater safety. Can you elaborate? Safer than what?
Well, for sure. So our inventor, Ryan Woodley, who's our CTO, Chief Technology Officer, has spent 20 years in natural gas well sites. And he remembers very well, trying to get out of a separator shed because his eyes were burning and his lungs were burning. And so we know that without fuel gas, we completely eliminate any of the venting emissions from the pneumatic devices, actuators, pumps, controllers, and so forth. So there's zero emissions, and we completely reduce the LEL level in the separator shed. We can go from a class 1 group 1 to a class 1 group 2 environment. Really improves costs and safety for the operators.
Similar line of questioning, are there any safety concerns over using hydrogen peroxide?
Hydrogen peroxide actually is a very, very safe chemical. It's being used throughout the world. That's transported every day. Transport is highly regulated and certified. In our particular system, there is no need for operators touching anything. We have qualified individuals who do that. And in fact, Houston is a hub for the use of hydrogen peroxide. So it's a very well understood and there are standard operating procedures that are well accepted in the industry for its use.
All right, if there's no further questions, thank you so much, Clint. We'll move on to the next speaker. Our next startup is Cannon Energy, our last House of Walkman startup. We will hear from Randy Rutherford. Randy was voted most likely to change Montana State motto of gold and silver to gold, silver, and waste heat energy.
All right, not sure what to say about that intro, if I should be flattered or not, but I'll go with it. Thank you. So thanks everyone for being here, for your support of Rice Alliance and just everything that you bring to this program. I'm Randy Rutherford. I'm VP of Business Development at Cannon Energy, and we are a turnkey developer of industrial waste heat to power projects. Today, we're looking for corporate partners who are interested in deploying decarbonization projects at their sites. Here's the problem we address. Over half the energy delivered to an industrial facility is wasted. Often it just goes up in the smoke as rejected thermal energy. And we help manufacturers monetize this waste heat and reduce their carbon emissions. And it doesn't have to cost them a dime of their own capital. I'll get to that in a second. But first, why is this important? Well, because if you're a CEO in this space and heavy industry, you're under the microscope and in the crosshairs of multiple stakeholder groups to decarbonize your operations and to do it quickly. We help our partners meet this threat head on by delivering quick ESG wins and allowing them to emerge as ESG leaders in within their industries. The technology we use is commercial. It's off-the-shelf organic Rankine cycle waste heat to power technology. It's well deployed in Europe, but not yet here in North America. And so we asked ourselves, why is that? And we landed on a couple of roadblocks. First, despite the relatively straightforward concept of waste heat recovery, it's actually a very complicated and complex development process, requires expertise, across many different functions to really monetize all the project benefits. But perhaps more importantly, we identify what we call a misalignment of capital. These are large energy infrastructure projects. They don't have 2-year or less simple paybacks. They don't rise to the top of the corporate budgeting stack. So Cannon brings full scope development expertise, and we bring patient capital to these projects. It's a business model innovation that represents a new way to deploy existing technology. And again, we can do this at no cost to host facilities. Here's how it works. We go in and help identify and evaluate waste heat resources at large industrial manufacturers. If we find something that looks like a viable project opportunity, we'll come in and provide all the project development, all the detailed design, the EPC, commissioning, construction, O&M, all with funding from our financing partners. Then this third-party owned project will sell power back behind the meter, back to the host site, often at a discount to existing power costs on a long-term stable power purchase agreement. Our industrial partners benefit from lower cost, reliable power, but what we've really found resonates here, the real value is the replacement of grid power purchases with clean, baseload, emission-free electricity generated behind the meter. So it's a clear Scope 2 emissions reduction story. It delivers a firm win against corporate ESG objectives. Our target industries here are the usual suspects where excess waste heat is generated. Our projects range in size from a couple hundred kilowatts to up to around 20 megawatts. This profile on the right is actually our first project in development. It's a natural gas compressor station in the upper Midwest, about 11 megawatt project, and it will deliver over 50,000 metric tons of CO2 reductions annually. This customer actually just notified us a couple of weeks ago that they now want to pursue 4 of these stations simultaneously, as opposed to just this one. So between a couple of existing customers, about 10 term sheets outstanding, we have very strong market validation for our value proposition. And one of the reasons is because we can deliver these benefits better than anyone else on the planet. We have a very unique team. As I said, we have full scope skill sets. We implement these projects in a way that we think technology providers, engineering firms, other developers would have a hard time doing and bringing those skills to the table. Again, this includes expertise in power and environmental markets, ORC technology, policy and legislation, project finance, the whole gamut. A little bit more about our team. Prior to founding Cannon, our team members designed and deployed about 50 megawatts of ORC projects here in North America. They're still currently operating. Jake, our Chief Technology Officer, has about a decade of experience engineering and constructing energy infrastructure projects, including commissioning a very large $1 billion oil sands facility in northern Alberta. He's also designed and built a proprietary Stirling engine. Dan, over here in the lower left, our Chief Development Officer, has a decade of experience in power and environmental markets. And Janice, who I believe you'll have the pleasure to meet shortly here, is our CEO. She was an early employee at Generate Capital out in Silicon Valley. She deployed over $500 million in energy assets there, and she was recently featured in Forbes magazine. Through Janice's past experience and really since founding Cannon, we as a company have been deeply embedded in the climate tech ecosystem. So finally, we'd welcome any interested corporates to reach out and get in touch, any manufacturers with waste heat over about 300 degrees Fahrenheit. We'd love to chat with you to see if we can look at power production potential at your site. Again, at the end of our process, our goal is to deliver a decarbonization win and help your company emerge as an ESG leader in your industry. So with that, I'll wrap and say thanks to Rice and everyone here today.
Thank you so much, Randy. We'll spotlight Janice so she can join us for the question and answer portion, and we'll turn it over to our attendees for questions. We have our first from Vincent. Does the model you want to pursue in the US exist in Europe already, or are there European projects based on a traditional CapEx model?
Yeah, I can take this one. So we right now are really focused on United States and Canada. That's just where our network is. That being said, we recently started conversations with a large utility in the United Kingdom. So that's our first real project in Europe. We know that the European market is great. We have an investment partner that is active in Europe. So we would love to go there. It's just a matter of bandwidth. But no, the European projects would not be based on a traditional CapEx model. It'd be based on the model that you're currently seeing today, if not even better, because there's lots of really great incentives in Europe. So if you have projects, we would love to go there. Just give us a shout.
Next question, Raj, from the chat. What's the typical payback period for your project look like?
The typical payback periods really depend on a function of the revenue. So because our projects can sell both behind the meter, back to the host or to the grid, that power price kind of varies. So in some cases, they can be as long as 7 to 10 years. Some cases they can be 2 or 3. It really depends on the available incentives. I'd say the average is about 5 to 7 years on average. If you look at typical payback periods required of like say a cement plant or an oil and gas facility, they're typically looking at 2 years or less payback. And so that's a really big reason why traditionally this waste heat to power sector hasn't really picked up. But by bringing dedicated infrastructure capital that is comfortable with the longer payback times, that's how we're able to unlock this sector.
Okay, next question from Hani. Are there geographic areas that make more sense for waste heat recovery or for waste heat energy to be economical? In other words, colder climates due to the larger temp difference?
I can start on that, Janice, and let you chime in. Certainly the colder environments help a slight bit with efficiency in terms of power generation. It's not too significant. We'll derate maybe 5 to 10% of power output based on the ambient temperature. Again, as you mentioned, colder ambient being better. Really, our projects are targeting jurisdictions and geographies where we see attractive and favorable economic incentives. And Janice, if you want to speak to how we go about doing that and how that plays a role in our economics.
Yeah, like I said before, it's really a function of grants, different types of power rates. So in regions where the power rates are high, so you're seeing like kind of the coastal regions, that would be the highest payback periods, the highest returns. That being said, we don't necessarily need the highest returns to make these projects go. We're kind of looking for a kind of minimum hurdle rate, and we're seeing projects even in the Midwest and the South still work.
From Farouk. Do you have any optimization or proprietary processes?
Yeah, so the quote unquote IP that we have is really in our sales process, our screening and scoping of projects. So as a development company, we actually pride ourselves in being technology agnostic. So we're really looking at there's a lot of really great technology providers that's already out there, and it's constantly changing and evolving. So we're trying to get the best technology as it changes and evolves, and we find that technical fit for our partners. Where we come in and are special is how we integrate that into the facility, how we manage the execution, and into the streamlining of our operations for the customer. And then finally, our optimization of the different revenue, like electricity markets, the grants, carbon markets, all that stuff. That's definitely in our wheelhouse and something that traditional EPCs or traditional tech providers won't quite have extensive knowledge in.
All right, we're actually out of time, though there is one more question in the Q&A that y'all can address afterwards. 2 more. Thank you so much, Randy and Janice.
Thank you.
All right. Well, thank you, Caroline, Gulati, Ali, Clint, and Randy. With that, we'll wrap up the House of Walkman pitches, and that actually wraps up all of our pitches this afternoon. I'd like to quickly say hi, if I can be spotlit. There I am. I'm Matthew Pena, the Associate Director, and you've been hearing from me behind the curtain this afternoon. I'd like to take a quick moment to congratulate the 12 startups that presented today. All have made significant progress over the last 12 weeks with our help, but especially by their own initiative. Remember, and this goes for the startups, the Rice Alliance is a resource you can reach out to in the future. This relationship doesn't end after today, okay? This goes for our attendees. The inaugural class was a pleasure to work with. Egos were never an issue. The group was big on engagement and friendliness. This cohort demonstrated that Canada doesn't have a monopoly on kindness, but it certainly helps to have them amply represented. And I look forward to meeting all of you in person at the Energy Tech Venture Forum in January. I'll now turn it over to Carrie.
Thank you, Matt, and congratulations, founders. I may or may not have been doing a Snoopy happy dance as you were wrapping up with your remarks, Matt. So nicely done. And for the non-boomers still with us today, if you want to Google Snoopy happy dance, you'll see just how ridiculous I look in here in my office. But founders, we're excited for what's in store for you. And we raise a glass to say congratulations and well done. And to our audience, keep in mind that their work doesn't stop today and that it continues. We invite you to explore ways in which you can continue supporting our founders going forward. And before we go, I'd also like to take just a brief moment or two to acknowledge and thank all of the people who have helped make this Accelerator program and this demo day possible. To Wells Fargo and our supporting organizations, the tremendous support that you provide us has enabled us to offer this unique program and has been truly an honor to experience. We appreciate your very early involvement in helping us to collectively build out our vision. Your leadership and support allowed all of us to be here today. And to our energy network, thank you all to our energy sponsors who have supported the Rice Alliance over the years and provided such a broad and deep network for the hundreds of startups that participate in all of our energy-focused programs. We thank you too. And to our Energy Advisory Board, your early direction, guidance, and support helped us plan for and deploy this first cohort. We look forward to your leadership in building more energy-focused programs that will continue to position Houston as a leader in the energy transition space. To our mentors and speakers and advisors and our XIRs and all of the other amazing people that chipped in and provided content this summer. You are our not so secret, but essential sauce. Thank you for answering my emails and jumping in where needed. I hope that you saw your pearls of wisdom woven through today's program and will continue advancing our entrepreneurial ecosystem through your generosity and time. We'll be calling on you again, wink, wink. And to the Clean Energy Accelerator and Rice Alliance teams, your commitment to supporting this ecosystem does not go unrecognized and should be applauded. Thank you for stepping up whenever help or guidance was needed. And I also want to extend a special thanks to the ION and to Courtney Cogdill. Their support allowed us to leverage talent and resources through our partnership with the ION Acceleration Hub. And finally, to this amazing group of curious, fun, and super talented founders. We are so thankful for the inspiration, the collaboration, and the drive that you brought to this cohort. I can only imagine how awesome you are in person. And at the risk of sounding a little like a Chick-fil-A representative, it has been our pleasure to serve you. So that's a wrap for our very first demo day. We invite you to connect with our startups and explore the exhibition booth for the next little bit. Also, remember to mark your calendars for January 27, 2022, and plan to join us in person when we'll host the Energy Tech Venture Forum at Rice. I know I'm looking forward to meeting my founders in person at that time, and I hope to see you there too. And finally, if you're a clean energy entrepreneur looking to be a part of Class 2, we invite you to watch for announcements on our website. We'd love to learn more about the work you are doing. Great job, everyone. Cheers, and thank you all.